Hello my dear students, welcome to the lecture series of methods of differentiation, and this is our lecture number 7, and in this class we are going to discuss the second part of the chapter, logarithmic differentiation. This is the second part and the last part of the chapter. Okay, so let's get into the video. Continuing the previous class, we are going to discuss about some problems of the chapter logarithmic differentiation. So find dy dx, and we are taking the question number 22, and the question is y to the power x plus x to the power y plus x to the power x is equal to a to the power b. So this is our question, and this problem is slightly different from the problems discussed in the previous class. You see, in the previous class, in those problems, the functions are not connected by this plus or minus sign. Here you see, since the base and powers in all of the terms here, base and powers, these are variables, so we must take logarithm. Okay, so we must take logarithm here. But you see, we cannot take logarithm here directly, because y to the power x, you see here, plus x to the power y plus x to the power x is equal to a to the power b. This is our problem now. So if you take logarithm here, so if log of this whole term is remaining same, is equal to, it is log of a power b. But you see, this logarithm, this one cannot be distributed, mean you cannot write log of y to the power x plus x to the power y plus x to the power x is equal to, you cannot separate the logarithm, mean you cannot write log of y to the power x plus log of x to the power y plus log of x to the power x. You cannot take like that, mean the terms are connected by positive sign or negative sign. In those cases, you cannot distribute this log into all of the terms. If they are in the product form, that means if these plus signs are in product or division format, then you can use logarithm directly, because in case of product case, in case of product format, if you take logarithm, then those products will be converted to plus when you distribute the logarithm in the given functions. Or if the functions given here is in the format of quotient, mean division format, then if you take direct logarithm there, then it is also distribute the logarithm by taking minus sign between the terms. You got my point? মই ক'ব খুজিছোঁ যে যেতিয়া এইবিলাক টাৰ্মছ প্ৰডাক্ট হৈ থাকে, ইনটু হৈ থাকে, সেই কেছটোত মই কি কৰোঁ, লগাৰিথমটো যদি ডাইৰেক্ট লওঁ, তেতিয়াহ'লে সেই প্ৰডাক্টছবিলাক লগ বস্তুটো ডিষ্ট্ৰিবিউট কৰি দিয়াৰ লগে লগে সেইবিলাক কি হ'ব, প্লাছ চাইনেদি কানেক্টেড হৈ যায়। কাৰণ we have a property of logarithm that log of u into v is equal to log u plus log v. Product থাকিলেহে সেইটো প্লাছ হৈ সেপাৰেট হয়। But if the terms are already separated by plus sign, then you cannot take logarithm here. যদি টার্মস বিলাক অলরেডি প্লাসে দিয়ে কানেক্ট কৰি থোৱা আছে, তেতিয়াহ'লে তুমি যদি লগ লগাই দিয়া, তেতিয়াহ'লে সেইটোৰ পৰা তুমি সেপাৰেট কৰিব নোৱাৰিবা, বিকজ we have no property of logarithm that log of u plus v is equal to log u plus log v. হেতুতো মই লিখিব নোৱাৰো নিশ্চয়, তোমালোকে তো জানা যে যদি মই লিখো log of, এটো সিম্পল কথা এটা, log of u plus v এনেকে ধৰি যদি আছে, তেতিয়াহ'লে এটো তুমি নিশ্চয় লিখিব নোৱাৰিবা log u plus log v। এটো বস্তু লিখিব নোৱাৰি, তাৰ মানে যেহেতুকে এটো বস্তু লিখিবই নোৱাৰি, এটো বস্তু যেহেতুকে লিখিবই নোৱাৰি, গতিকে আমাৰ যেটো প্ৰবলেম আছে যে এই প্ৰবলেমটোত আমি ডাইৰেক্ট লগাৰিথম লোৱাটোৰ কোনো মিনিঙে নাথাকিব, কাৰণ আমি তো তাক লগাৰিথমটো সেপাৰেট কৰিবই নোৱাৰো। একচুয়ালি আওয়ার টার্গেট ইজ হোয়াট, আমার টার্গেট হয়েছে এই যে পাওয়ার্স বিলাক আছে, এই পাওয়ার্স বিলাক যাতে পাওয়ার্সত না থাকে, এটো যাতে প্রোডাক্ট ফরম্যাটত আহি যায়, আর তার কারণে তো আমি লগারিথম লবই লাগিব। বাট ইন দিস টাইপস অফ প্রবলেম হোয়ার দ্য টার্মস আর কানেক্টেড বাই প্লাস অর মাইনাস সাইন, দেন ইউ ক্যানট টেক লগারিথম ডাইরেক্টলি, কারণ সেই সময়ত তুমি ডাইরেক্ট লগারিথম ললে তুমি এই প্রপার্টিটো নোপোৱা, আৰু এইটো প্রপার্টি যদি নাপাও আমি, তেতিয়াহ'লে তো লগ লোৱাৰ কোনো মিনিঙে নাথাকে। সেই কারণে এইবিলাক প্ৰবলেমছত অলপমান মেথডটো ডিফাৰেণ্ট হ'ব প্ৰিভিয়াছ কুৱেশ্যনছ কটাত কৰি ধৰিব পাৰিছা নিশ্চয় গতিকে হোৱাট ইজ দ্য মেথড নাও মই অলৰেডি কৈছোৱে তোমালোকক যে যেহেতুকে বেস আৰু পাৱাৰ এই দুটা প্লেসতেই ভেৰিয়েবলছ আছে তো লগাৰিথমটো মাষ্ট লাগিবই কিন্তু টাৰ্মছ বিলাক আমাৰ প্লাস বা মাইনাস সাইনেদি কানেক্ট হৈ থাকিলে তেতিয়া হলে আমি লগাৰিথম ডাইৰেক্টলি লবও নোৱাৰো কাৰণ হেতু কৰিলে আমাৰ কোনো বেনিফিট নহয় no benefit we will have so therefore we have to use a different method here so that method is discussing in this video so you concentrate to the class so see what to do in this case actually these types of problem can be done in two methods দুটা মেথডছত আমি এইবিলাক সলভ কৰিব পাৰিম দুটা মেথডত সো আমি দুটা মেথডে এইটো কোৱেশ্যনৰ কাৰণে মই দুটা মেথডে ডিসকাশন কৰিম তোমালোকৰ যেটো ভাল লাগে হেতু কৰিব পাৰিবা নো প্ৰবলেম এটো এক্সামত একো অসুবিধা নহয় সো দা ফাৰ্স্ট মেথড ইজ দিস ইজ ইউজুয়াল মেথড তো প্ৰথম মেথডটো আমি চাই আছো সো ফাৰ্স্ট অফ অল ইউ আৰ টু টেক দিস থ্রি ফাংশনস one of the function is taking as u the second one is taking as v third one is taking as w if you have more functions then you also take t s etc তুমি এনেকে থাকিলে যেতিয়া প্লাস বা মাইনাস চিনেদি কানেক্ট হৈ থাকিব ইউ লবা এটা ভি লবা এটা ডব্লিউ আর এস টি যেনেকৈ আছে যিমানটা আছে সিমানটা লৈ লবা ওকে এন্ড দেন ইউ দিস ইজ এ ফাংশন অফ x or y this is also a function of x or y this is a function of x and then from those functions we can find the derivative in usual methods that is discussed in earlier video so then you replace this value u v w this line will convert it to u plus v plus w equal to a to the power v you see here a to the power v is not substituting here আমি a to the power v মানে ধৰি লোৱা নাই তাৰ কাৰণটো কি জানানে কাৰণ ডিফাৰেন্সিয়েশন কৰিলে মোৰ a to the power v এটো যেটো এটা কনস্ট্যান্ট টার্ম this is a constant term so it will automatically removed to 0 to 0 হৈ যাব so that is why we are not taking this as some new function এটো আমি ধৰাৰ কোনো দৰকাৰ নাই কাৰণ এটো যদিও আমি ধৰিও লম কিবা এটা বস্তু তেতিয়া হলে ডিফাৰেন্সিয়েশন যেতিয়া মই কৰিম তেতিয়া হলে রাইট হ্যান্ড সাইড টু অলরেডি তোমার 0 হয়ে যাবে গতিকে আমি হেতু এই অবস্থাত রাখিলেও 0 হ'ব লগারিথম মানে u v w আৰু z যদি লং হয় তেতিয়াও হেতু 0 ই হ'ব because that is a constant number so that is why since this is a constant number a to the power b is a constant number therefore we are not taking here a new function for a to the power b okay so we will have u plus v plus w is equal to a to the power b this is our function now and all of this u v and w these are functions of x or y এইবিলাক x নাইবা y function হৈ আছে so now the question is to find dy dx therefore we are to take differentiation of this now with respect to x যেহেতুকে মোক dy dx সুধিছে গতিকে এই টার্মটোৰ মই ডিফারেন্সিয়েশন with respect to x ত আনিব লাগিব so with respect to x derivative কৰিলে u derivative will be du dx v derivative will be dv dx w derivative will be dw dx and the right hand side is obviously 0 because that is a constant number okay you see so differentiating with respect to x it is du dx plus dv dx plus dw dx is equal to this is constant so will be equal to 0 marked by 1 now we find du dx dv dx and dw dx by using these relations এই তিনিটা রিলেশনস ইউজ করি আমি a2 আর a2 এই তিনিটার ভ্যালুটো এক্সট্রাকে উলিয়াই আনিম so now u is equal to y to the power x this is our function we need the value of du dx এরপর du dx লাগে but you see this u is a function where base and power both are variables so we cannot take differentiation directly here as the method discussed in the earlier videos so that is why we use logarithm now this time we can use logarithm because the terms are not connected by plus or minus sign that is why you can take logarithm this time so log of u is equal to it is simply this x will come in front of logarithm so x log y one line is skipped here then you take differentiating with respect to x so the left hand side log u differentiation is 1 by u and for u the derivative is du dx So 1 by u, that is du dx, is equal to, on the right hand side there is the product of two functions x and log y. So x derivative is 1, log y remaining same, plus x is remaining same, log y derivative is 1 by y, and for y you are to write dy dx. So then du dx, we need du dx in equation number 1 is C, we need du dx. So du dx is equal to this, u will go to the right hand side as cross product, u into this is log y plus it is actually x by y dy dx, and that is equal to this, what is u? U was equal to y to the power x, and that is using here. This method is discussed in the earlier video. আমি আগতে অলরেডি পাই আহিছোঁ যে এনেকুৱা ধৰণৰ যদি থাকে y is equal to আছে এনেকুৱা তাৰপিছত লগাৰিথম লৈ পেলাই মানে ইউজিং the usual method, simple method. So we already obtained that the value of du dx is equal to this one. আমি du dx to পাই গলো. In the similar way, you take now v is equal to x to the power y. And in this case also, by taking logarithm, you can find dv dx. And similarly for w equal to, for w, you again take logarithm and then find the derivative. Okay, so now I am taking v equal to x to the power y. So v equal to x to the power y, so you can take logarithm here because the terms is simple term. So log of v is equal to y log of x. This y is coming in front of log by the property of logarithm. Now differentiate it, differentiating with respect to x, very simple. Then the left hand side log function derivative is 1 by v here because the function is of v. So 1 by v into, for v by chain rule you are to write dv dx. So 1 by v dv dx equal to, this is a product function again, y and log x. So y derivative is dy dx, log x is remaining same, plus y as it is, and log x is 1 by x, derivative 1 by x. So dv dx will be equal to v whole into this term. So dv dx is equal to v whole into this term, and this is equal to, what was v? V was equal to x to the power y we are using here, and the rest of the terms are remaining same. So we obtained dv dx also. And finally we need dw dx, and w was x to the power x. You see in your copy, w is x to the power x, again by the similar method used here, taking log of w is equal to, it is x log x only. Now take differentiation, differentiating with respect to x. So left hand side 1 by w dw dx equal to, this is a product function, so x derivative is 1, remaining log x, plus x is similar same, and log x derivative is 1 by x. That is implying this w will go to the right hand side as cross product. So w into this log x remaining same, x and x cancel, so plus 1 is remaining there, is equal to, w was equal to actually x to the power x, and using here x to the power x into log x plus 1. So we obtained the value of du dx, dv dx, and dw dx, and using all of these three values in equation number 1. You see that this is equation number 1. So 1 implies, the first term was du dx, and this is the value of du dx, plus second one was dv dx, and this is the value of dv dx, plus then the third one was dw dx, and this is dw dx, and on the right hand side it was simply 0. Now you use the usual method of implicit function, derivative of implicit function discussed in previous classes. So from here what to do? From here we are to collect those terms involving dy dx. So here this term is dy dx, this is involving dy dx, so we should take dy dx common, and all other terms not involving dy dx to be shift to the right hand side of the equation. Okay, so we are taking dy dx common here. So dy dx into, you see this and this term, if you take the product, it is y to the power x into x by y into dy dx, but dy dx is taking common here, so we will have y to the power x into x by y, this one, plus come here the term involving dy dx. Dy dx is already taken away, so the term remaining is x to the power y into log x. this one x to the power y into log x is equal to all other terms not involving dy dx will be shifted to the right hand side, and those terms are y to the power x into log y, x to the power y into y by x, and this total term, and all of these terms will go to the right hand side and they will be negative. So minus is taken already common, so it is y to the power x into log y, and this term is x to the power y into y by x, and this term is x to the power x into log x plus 1. And now simply you can resolve this y to the power x minus 1 here, and here x to the power y minus 1 by using index property. So dy dx is equal to, this minus is remaining same, this term is remaining same, plus this is actually x to the power y minus x into y, plus this is as it is and divided by this term, and here it is actually y to the power x minus 1 into x, plus this term is remaining same, and this completes the solution of the problem. This is the usual method, and this method is given in your book. এই মেথডটো তোমাৰ বুকত আছে, সো তুমি যদি এনেকে ভাল পোৱা তেতিয়ালে এনেকেই কৰিবা হা। আৰু এটা অল্টাৰনেটিভ মেথড মই ডিসকাশন কৰিম, আৰু সেইটো মেথড তুমি ইয়াত কৰি ইজি পাব লাগে, মানে শৰ্টাৰ হ'ব, ইয়াত কৰি ক্যালকুলেশনটো অলপমান শৰ্ট হ'ব। সো ইউ সি দ্যাট অল্টাৰনেটিভ মেথড অলসো, you may use any one of these two methods in your exam. So the alternative method, this is recommended. মই তোমালোকক এইটো মেথড কৰিলে বেছি ভাল পাম, কিন্তু অসুবিধা একো নাই, তুমি সেইটো মেথড কৰিলেও কোনো প্ৰবলেম নহয়। Okay, so the problem was y to the power x plus x to the power y plus x to the power x equal to a to the power b. This is our problem. So this time the method is to take logarithm here. Logarithm to moi loboi lagibo, but they are connected by plus sign, so we cannot take logarithm here directly, but we can use a property of logarithm here as like this. You see, moi tumalokok dekhai dibo parim je lobman saba eta property asil noy logarithm, so e to the power log of, say it is the x thake, this base may not be there, eto nilikhilo tumi e buliye bhabibo lagibo. So what is the value of this? Is it not equal to y, sorry x? Eto to ami already koisu, that is actual property to moi likhisilo eto a to the power log of x to the base a, and that was equal to x, and here yate amar log to লগৰ বেস যেটো হেতু ই হৈ আছে, তো অ্যাকচুয়াল প্রপার্টি এটো মিন দিস বেস এন্ড লগারিথম বেস এই দুটো যদি সেম থাকে তেতিয়ালে এইখিনি এই টার্মসখিনি রিমুভ হৈ যায়, মানে থাকি যাব মাত্ৰ x. So here also a to the power log of a base x, so removing this term you will have only x. So মই এই প্রপার্টিটো ইয়াতে ইউজ কৰিব লাগিব, individual term in this term also, in this term and in this term, individual term, because you cannot take logarithm directly here as the terms are connected by plus sign. Okay, so I am going to use this property here, and that is, since we need y to the power x, so this y to the power x should be written here. ইয়াতে y to the power x লিখি দিলে হল, কারণ এইখিনি বস্তুটো অলরেডি রিমুভ হৈ যাব, তার মানে you should write e to the power log, এইখিনি লিখিলে এইখিনি লিখা আৰু নিলিখাটো তো মিনিংলেস জানাই, মানে হেতু রিমুভ হৈ যায়, আৰু যেটো গিভেন টার্ম হেতু ইয়াতে লিখি দিলে হল। সো দ্যাট ইজ লাইক দিস, e to the power log of, এইখিনি মই এক্সট্রা কে লিখিলো, and y to the power x is as it is here, because this total term is nothing but y to the power x. Actually I am not writing the base of logarithm here, but if we do not write the base of logarithm, we should note that that base must be e, aru hetu e hoy boli ami janu jodi likhu, ei karone moi eta likha nai. So actually this term y to the power x is already here, moi extra ke loisu mane e to the power log, e to the power log likhile etu actually remove hoy ase, that mean you have the term y to the power x already, so etur thait moi etu likhibo paro. In the similar way x to the power y, this x to the power y is already here, e to the power log yate extra ke logai diar loge loge etu aru etu ekai term bujabo, plus this term, in this term also e to the power log লিখি পেলাই এই যেখানে টার্মস আছে টু অ্যাজ ইট ইজ রাখি দিবা। In this term it is not necessary to write because the right hand side is already a constant, so in the process of differentiation this will be automatically 0, it is 0 হয়ে যাব, গতিকে আমি এটো লিখার দরকার নাই, বুঝি পালানে? so now use the property of logarithm in the power, a power to logarithm property use করে, তার মানে this x will come in front of log, this y will come in front of this log, and this x will come in front of this log. So that is e to the power x log y, e to the power y log x, e to the power x log x, and equal to a to the power b. এতিয়া চোৱা তুমি base আৰু power দুটা variable নাই. Now there is the term not having the base and powers are variable. So now it is quite possible to take differentiation because we have a formula for e to the power something. We have formula for differentiation, e to the power x, differentiation is e to the power x itself. গতিকে তার কারণে যেহেতু ফর্মুলা আছে, so it is quite possible to take differentiation in this line now. ইয়াতে কিন্তু লব পারা নাছিল মই because base and power all are variables, but this time it is not in that format, এটো এটা মানে straight function হয়ে গেছে. So now we can take logarithm differentiation. Line to more double হয়ে গেল এখন নাই. So differentiating with respect to x, এটা যদি মই differentiation করো তেতিয়া হলে first come to this one, e to the power something, differentiation will be the function itself because the derivative of e to the power x is e to the power x itself. So derivative of e to the power x log y is e to the power x log y itself into, by chain rule you are to write the derivative just the power by chain rule, because this is not actually x. The formula for we have the formula for e to the power x, not for e to the power x log y. Therefore first use the usual formula, then by chain rule the term you are considering as x, you are to take differentiation of that term also. You see here this e to the power x log y derivative is e to the power x log y, it is remaining same. Now by chain rule to take the differentiation of this power, mean x into log y, and this is a product function, x derivative is 1, log y is remaining same, plus x is remaining same, log y derivative is 1 by y, into, for y you are to write dy dx by chain rule, simple, plus here derivative of e to the power y log x is itself into derivative of this power, y derivative is dy dx, log x remaining same, plus y remaining same, log x derivative is 1 by x. Come to the third one, plus this one, e to the power x log x derivative is e to the power x log x itself, then take the differentiation of the power by chain rule. So x derivative is 1, remaining log x same, plus this x is remaining same, and log x derivative is 1 by x, equal to, right side is a constant number, so differentiation is equal to 0. So this is the line, Now you see e to the power x log y, it was actually this term, e to the power x log y this term, and that was nothing but this term, and that is actually y to the power x, mean in this place you can replace again y to the power x, in this place you can replace x to the power y, and in this place you can replace x to the power x, because this one was actually this one, and that is e to the power log of x to the power x, and that is nothing but x to the power x only, because log and e will remove this one. Now you write that line, it is y to the power x, this is x to the power y, this is x to the power x, and the terms remaining same here, then collect the terms involving dy dx, mean this term and this term, all the terms not involving dy dx to be shifted to the right hand side. So dy dx, here dy dx is taking common, y to the power x into this term, y to the power x into x by y, plus come here y to the x to the power y into log x, dy dx is already taken common, is equal to the terms this one and this total term will go to the right hand side, and all of them are negative. So minus y to the power x log y, then this one x to the power y into this term, it is actually minus, but minus is taken common, so it is plus this one, and x to the power x log x plus 1, this one, it is a negative term, but it is taking common in the right hand side, negative is taking common in the right hand side, so it will be plus. So now you can resolve this y to the power x minus 1 and here x to the power y minus 1, and then division. So dy dx is equal to, minus is there, this is same, this is x to the power y minus 1, y is remaining same, this term is same, this is y to the power x minus 1 into x and plus this term, division. Okay, so this is the solution for the question. So you may use the previous method or this method, both the methods are acceptable. Okay, so come to the next question. X to the power y plus y to the power x is equal to 1. It is exactly similar to the previous question. In the previous question, one extra term was there, x to the power x, and that term is not given here, and the right hand side is 1. Obviously this is a constant, so you can solve this problem by the help of the previous question. So this is homework for you, and you can solve this problem. Important question. Actually, if this question asked in your exam, 6 marks will be given. Okay, so you should read or practice this types of problem for your final exam. Then I am taking the next question, number 24. Y is equal to x power x plus 2 to the power x, and in this function you see the two terms are connected by plus sign, so you cannot take logarithm directly here. Okay, and secondly here the base and powers are variables, so you must take logarithm, but here you cannot take direct logarithm. For 2 to the power sin x we have formula. This term is not headache for us. This term is not headache for us. This is the term x to the power x. So here also you may use two methods by taking this term as u, this term as v, then u part taking log, then du dx find. V part you may take log or you may not take log, because 2 to the power sin x has the differentiation 2 to the power sin x into log 2 into cos x. You can directly write that one. But here I am using the second method. Y is equal to, this is the power, in power of e, you write this term in power of e like this, e to the power log, this is the extra term, and x to the power x is remaining same. And in this term it is not necessary to take in powers of e, because the base is constant and power is variable, so we have a formula for this one. So here I am not taking e to the power. But if you take e to the power log of 2 to the power sin x, no doubt the answer will come out, but here it is not necessary actually. So now use the property of logarithm here. So y is equal to e to the power, this x is coming here, x log x, and this term is remaining same. Now on the right hand side you see base and powers, these powers are removed as a product now, therefore you can take differentiation directly here. So dy dx is equal to, now differentiate the first function, this one, e to the power x log x, and e to the power some function derivative is the function itself, into, now take the derivative of the power function x into log x. X derivative is 1, so log x remaining same, plus x is remaining same, log x derivative is 1 by x, plus come here 2 to the power sin x, it is the formula a to the power x. So what is the formula? You see d dx of a to the power x, d dx of a to the power x was equal to a to the power x into log a. You know this formula, into log a. And here you see here a is 2, so differentiation of a to the power x means 2 to the power sin x will be 2 to the power sin x into log of 2, so 2 to the power sin x into log of 2, but it is not x, it is sin x. So by chain rule, to write the derivative of sin x also, that is simply cos x. Okay, so now this x is cancelled, and this term to be replaced by x again, x to the power x again, because it was actually this term, that was actually this, and finally it is simply x to the power x. So here you are to write x to the power x, this will be 1 and this term will remain same. So it is x to the power x log x plus 1 and it is remaining same, and that completes the solution of the problem. Okay, so I am erasing this one. Now we take another question of the same type. Y is equal to x plus 1 by x to the power x plus x to the power 1 plus 1 by x. You see both the terms, this one and this one. Base and powers, this is the total base and power, here base and power, base and power both are variables. So logarithm is compulsory, but you cannot take logarithm here as the terms are connected by positive sign. So here also you are to write this term and this term in the powers of e to the power log of this term, and here e to the power log of this term. You may use the usual method by taking u plus v, y equal to u plus v, then dy dx is equal to du dx plus dv dx. Then u differentiation and v differentiation, you find those two differentiations separately and finally use that two values here. We'll get the answer. That is the usual method, but I am using the second method. Y is equal to e to the power log of the term itself plus here also base power variable, so e to the power log of this term. So this power is coming here and this power is coming here. So y is equal to e to the power x log of this plus e to the power 1 plus 1 by x log of x simply. Now find derivative, because now the power is not variable. Base and powers are not variables here, so you take differentiation directly here. So dy dx is equal to e to the power something, derivative is same, then power function derivative x derivative product, it is x into log of this, so x derivative is 1 log x plus 1 by x remaining same plus x is remaining same, log derivative is 1 by this term, 1 by this, into, then by chain rule x plus 1 by x derivative is x is 1 and 1 by x derivative is minus 1 by x square. This is minus 1 by x square. Okay, this is the formula for 1 by x to the power n, and the formula was minus n by x to the power n plus 1, and that formula is using here. Come to the second one, e to the power some function, derivative is itself, into, now differentiation of this power. So 1 0, it is product function 1 plus 1 by x into log x. So 1 plus 1 by x derivative is 1 is 0, 1 by x derivative is minus 1 by x square, log x remaining same plus 1 plus 1 by x remaining same into log x derivative is 1 by x simply. Okay, so this term was actually this one, so this one, so it is x plus 1 by x whole to the power x right here, and simplify here, and in this term you replace by this term and simplify here. So this is the term x plus 1 by x whole to the power x into, this is log of x plus 1 by x remaining same plus taking LCM here, so it will be x square plus 1 by x, and that x will go to the numerator. So that x and x is x square divided by x square plus 1 into, here taking LCM, it is x square minus 1 by x plus this term is nothing but this term, so writing here, and here it is log x by x square, this one negative is already there, and here x plus 1 by x, x plus 1 by x into x, it is x square now, so here it is x square, x plus 1 by x square. Now this x square cancel, and here this x square can be taken common outside. This term is remaining same, this is remaining same, it is x square cancel, so x square minus 1 by x square plus 1 plus same, this is actually this x square is taken as common, so it is x square by using the index property x to the power 1 plus x by x square. So this is nothing but x to the power 1 by x, this one I am writing here, you see, actually I am writing ddx of it is sorry, it is x to the power what? X to the power 1 plus 1 by x, 1 plus 1 by x, and I am taking x square common, and inside term remaining same. Inside term, this is simply log minus log x plus x plus 1. Okay, minus log x, this one minus log x plus 1 is remaining same. And now you apply the property x to the power 1 plus 1 by x minus 2. This 2 will be here. It is actually x to the power 1 plus 1 by x then minus 2, and that is finally x to the power 1 by x minus 1. That is finally x to the power, it is 1 by x, this is minus 1 writing here, and these terms minus log x plus 1 is remaining same. So that is the solution for the question. First I am erasing this, just a minute. Okay, so that is the solution for the question. Take the next question. Y is equal to log x whole to the power x plus x to the power log x. Nothing but base and power are variables, base power variables, so we must take logarithm, but the terms are connected by plus sign, therefore you cannot use logarithm directly here. Therefore you are to write these terms in the powers of e to the power log, e to the power log this term, and here also e to the power log this term. So important question actually. So y is equal to e to the power log of, the term is remaining same, plus e to the power log of this term is remaining same, x to the power, because e to the power log this will remove, e to the power log this will remove, the term remaining this one and here this one. Okay, so now use property, this x is coming here and this log x is coming here. So y to the power, y is equal to e to the power x into log of log x, this log of log x plus log x into log x, and that is simply log x whole square. You do not write log x square. Some students like this, write like this. Some students may write log of x square, but that will be wrong. It will be wrong. You should write log x whole square. Log x into log x is equal to log x whole square, not log x square. Okay, so you see the differentiation now, because in the power and base there is no variable, powers and base are removed here. So take differentiation, dy dx is equal to e to the power, the function remaining same, e to the power function derivative is this, and here the derivative of x into log of log x, product function x into log x. So x derivative is 1, log x same, plus x is same, then derivative of log x. So first log derivative is 1 by log x, and then log x derivative is 1 by x, plus now this term e to the power log x whole square derivative is itself into, now log x whole square differentiation is 2 will come out, index property 2 is come out, 2 into log x to the power 2 minus 1, mean x to the power n format. So 2 into log x to the power 2 minus 1 is simply log x into, then by chain rule log x derivative is 1 by x only, and now this term should be replaced by log x whole to the power x, and this term should be replaced by x to the power log x. So log x to the power x into this term is remaining same, and here x cancel, 1 by log x, plus it is 2 log x into this term is nothing but this one, so 2 log x, x to the power log x, and by x is this, and that's the solution for the question. And this question is homework for you, similar to this problem. Use logarithm here, e to the power logarithm here, but not here, because it has the formula sine inverse function derivative. We have a formula 1 by root over 1 minus x square, and here root over x is working as x, so by chain rule you are to take the differentiation of root x also, and that will be 1 by 2 root over x. So this function is possible to take differentiation directly, so need not to write in powers of e here. You are to write the powers of e here, because here base and power both are variables. So you should write log e to the power log in this term only. So you can solve this problem yourself, and this is also homework for you. So I am taking the next question. Y is equal to x to the power sin x plus sin x to the power cos x. And in this question also, base power in both terms, these are variables. So you should use e to the power log here and here in both the terms, e to the power log, e to the power log. If this term is product, then you can take direct logarithm here, but it is connected by plus sign. So you are to take logarithm in that method, e to the power log of this term, and here also e to the power log of this term. And that is y is equal to writing that term. So y is equal to this sin x is coming here, this cos x is coming here, then dy dx is equal to e to the power function derivative is same into use the product rule, sin x derivative is cos, log x same, plus sin x derivative same, sin x is same and log x derivative is 1 by x, plus in the second one e to the power function derivative is same into cos x derivative, this power function power part, cos x derivative is minus sin, log sin x remaining same, plus cos x remaining same, log sin x derivative, for log it is 1 by sin x, and for sin it is simply cos x. So dy dx will be is equal to, this term is replaced by x to the power sin x. You see here, this is cos x into log x, and it is sin x by x only, plus this term is nothing but sin x to the power cos x. So writing here, it is minus sin x log sin x, plus it is simply cos x into cot x, cos x into cot x. So that is the solution for the question. The next question is 29. Y is equal to this and this. It is an important question, and it is asked in your final exam 2 times. I think 2 times this question is asked in your final exam. So it is an important question. So y equal to x to the power x cos x plus x square plus 1 by x square minus 1. You see this term, in this term, first one, base and power both are variables, so you are to take logarithm here, but not this term, because this has the quotient rule, u by v format. So here we can take differentiation directly, but not here. So in this term you are to use e to the power log, but not in this term. Okay, so y is equal to e to the power, this term is written like this, plus it is remaining same, and here use the property of logarithm, x cos x will come here. So y is equal to e to the power x cos x, then into log x, plus it is remaining same. Now you can take differentiation, because now you see in base and powers both are not variable this time. So dy dx is equal to e to the power function derivative is itself into, now you see here are 3 functions, x, cos x, log x. 3 functions are there in product form. So first you take differentiation of x, these 2 remaining same, then cos x derivative, this and this remaining same, then x cos x derivative remaining same, log x derivative. Okay, so x derivative is 1, cos x log x remaining same, then x and log x remaining same, cos x derivative is minus sin x, so this is minus is taking here sin x, and x log x same, plus now x cos x same, derivative log is 1 by x only. Product function is used for u v w, so it is du dx here, then du dx, v w remaining same, plus u into d v dx into w, this one, and for this one u v dw dx, u v same dw dx, and here use the quotient rule only, denominator is square, that rule, denominator is square, then denominator into derivative numerator minus numerator into derivative denominator. So plus this is square, then denominator into derivative of x square plus 1, this numerator, this is simply twice x, minus x square plus 1, derivative of denominator is also twice x. So now this term is actually this, and finally it is simply x to the power x cos x. So it is x to the power x cos x, and here cos x log x. This x sin x log x remaining same, and here x and x is cancelled, plus cos x remaining there, and here 2x cube and minus 2x cube after completion of the product. 2x cube minus 2x cube is cancelled, and here minus twice x, and it is minus twice x, so simply minus 4x, and denominator is remaining same, and that is the solution for the question. The next question is y is equal to x cos x to the power x plus x sin x to the power 1 by x. Similarly, base power both are variables, so e to the power log here also and e to the power log here also. Writing like this. Similar problem. So e to the power, this x is coming in front of the function. Log of x cos x is simply log x plus log cos x. This product will be separated by plus whenever you distribute the logarithm in the terms inside log, like this. Plus 1 by x is coming here, and log of x sin x is log x plus log sin x. It is now differentiate. To dy dx is equal to e to the power function derivative is remaining same, and come here derivative of this term x into this, so x derivative is 1, product function 1, log x plus log cos x remaining same, plus this time x is remaining same, you are to write the derivative of this bracketed term. Log x derivative is 1 by x, and log cos x derivative 1 by cos, and for cos it is minus sin x. Okay, come to the second one, plus e to the power function derivative is itself, then write the derivative of the power. It is also a product function 1 by x into this one, so 1 by x derivative is minus 1 by x square. These terms are remaining same, plus now 1 by x is remaining same, write the derivative of this one. Log x differentiation is 1 by x, plus is here log sin x derivative 1 by sin, and for sin it is cos by the chain rule. Now just simplify. This term is nothing but this one, and this term is nothing but this one, and the bracket this term, simplify it and simplify it. So this is replaced by this term, and here it is log of, combining these two logs, log of x plus log of cos x is nothing but log of x cos x product, plus here complete the product, it is x cancel, so 1, this minus is here, and it is x into sin by cos is 10, plus it is the term, it's x sin x to the power 1 by x, this one, and here combining these two logs, it is log of x sin x is this one by x square, and negative is already there, and plus, and here you see just completing the product, it is 1 by x square, and here cos by sin is cot by x, and that is the solution for the question. You may write this line or you may not write. This is not compulsory, just taking x square common here, x square is taken outside of the bracket, so this is not compulsory line. You may leave the answer here or you may write here also. Okay, so I am taking the next question, number 31, and this question is homework for you. You can solve the problem by using e to the power here and here. In both terms use e to the power. In this question, this problem is actually what? This is x to the power x square. This is actually x to the power x square. Okay, and x to the power x square, take log on both sides. Log y is equal to, it is like this one, I am writing here for you. The problem is actually y is equal to x to the power x square, you see, but the base and power are variable, so take log, simply take log. Log of y will be is equal to, if you take log here, x square will come in front of log, so x square into log x, then differentiate, and finally dy dx will be equal to, you will obtain this. I think you can solve this problem. Okay, so this is also homework for you. Try yourself, try to solve this problem. If you have any problem, then ask me, I'll solve for you the question. Okay, the next one, y is equal to, this is the problem, and this problem is also solvable. You can solve this problem. Directly take logarithm, because here this term into this term divided by this term into this term. So if you take log, this product will be separated by plus, division will be separated by minus. These two terms, it will after taking logarithm, the terms will be like this. You see here, the terms will be log of what? Log of x plus 2 whole square, then plus this 2 will come here, this 2 will come here. This means 2 log x plus 2, then half of log x minus 1, then for denominator it is minus 2 will come out, log x minus 4, and then plus log x log e, sorry, x will come out, x log e, but log e is 1, this term is taken as 1, then take differentiation. In the left hand side you will have, log y, then take logarithm, and finally dy dx obtained from there, and you should also replace the value of y in the solution. So I am erasing this. Okay, so these 3 questions are homework for you. So this is our new question. Y is equal to e to the power x sine x square or plus cot of x whole to the power x. You see in this part, need not to write in the powers of e, because already it has the formula e to the power something. We have a differentiation formula, so need not to touch in this function. You just write e to the power log of this term, as here the base and the power both are variable. Okay, so you are to write e to the power log of this term in the second one, not in the first one, because the first one has already a formula. So we are writing here y is equal to, it is remaining same, plus e to the power log of this term. So y is equal to e to the power x into, this is remaining same, plus this x is coming here, x log of cot x, then dy dx is equal to e to the power function derivative is itself, and now the differentiation of the power x into sine x square. So x derivative is 1, sine x square is here, plus x remaining same, sine function derivative is cos x square is same, and for x square by chain rule it is simply 2x. Then plus, go to the second one, e to the power something derivative is itself into derivative of the power, that is x differentiation is 1, log cot x is as it is, plus x as it is, log cot x function derivative is 1 by cot x, and cot x derivative is minus cosec square x. Okay, so then just simplify it. So e to the power, it is remaining same, this is actually sine x square, and here x into x is x square, so 2x square is there, cos x square is already here, plus actually this term was this one, you see this one was actually this one, was actually this, and finally it is simply cot x to the power x. So we write cot x to the power x here, log cot x is same, this minus is coming out, x is already here, 1 by cot x is 10x, and cosec square x is remaining same. So that is the solution for the question. And number 35, find the derivative of this function. This is the given function, and hence find f dash 1. Find f dash 1, this is the second question. First of all, you find the derivative of this function. Okay, and it is in the format of the product of so many functions. There are 1, 2, 3, 4 functions are there. So use logarithm to differentiate it will be easy. Okay, so fx is equal to this, then log fx is equal to log of x plus 1, this product will be plus, log of 1 plus x square, this product is plus, log of 1 plus x to the power 4, then plus this product, plus log of 1 plus x to the power 8. So this is the function now, and now it is possible to take the differentiation. So differentiating with respect to x, so log function derivative is 1 by fx. By chain rule, fx derivative is f dash x. F dash x is simply dy dx, nothing but. The question is given in the format of y, so that is why I am writing f dash x. But if it is given as y is equal to, you are to write here dy dx. Okay, so this is equal to log of 1 plus x derivative 1 by 1 plus x. By chain rule, 1 plus x derivative is 1, simply need not to write here, plus this plus is plus, log 1 plus x square is 1 by 1 plus x square into 1 plus x square derivative is simply twice x, because 1 is 0 plus x square is twice x, plus for log function derivative it is 1 by 1 plus x square into this inner function derivative is simply 4x cube, plus log function derivative 1 by this term, and by chain rule the derivative of this one is 0 and it is 8x to the power 7. So f dash x mean dy dx is equal to fx into this total term. So f dash x is equal to fx into this total term. 1 by this, it is twice x by 1 plus x square. This is 4x cubed by 1 plus x to the power 4, and it is 8x to the power 7 by 1 plus x to the power 8. So this one. Now replace fx. Fx is this one. You put here. So f dash x is equal to fx is this one, and the rest of the terms are exactly same. Now this is the first answer of the question. Just find the derivative of this. It is the first answer. And also you are to find f dash 1. F dash 1 mean in this equation you just replace x by 1. So it is f dash 1 equal to 2 into 2 into 2 into 2 like this, mean 2 to the power 4 here, and here 1 by 1 plus 1 is 2, it is 2 into 1 is 2 by 2, this is 4 by 2, and lastly 8 by 2. So you write that line. This is the line already in the previous screen. So f dash 1 is equal to, this is 2 because x is 1, so 1 plus 1 is 2, 1 plus 1 is 2 into 2 into 2, mean 2 to the power 4. Here 1 by 1 plus 1 is 2, so 1 by 2, plus 2 into 1 is 2 by 1 plus 1 is 2, this is 4 into 1 is 4 by 2, and this is 8 by 2. By 2 to the power 4, 2 to the power 4 is simply 16. So it is 16 into, by LCM 2, so 1 plus 2 is 3, plus 4 is 7, plus 8 is 15 by 2. This is 8 times 8 into 15, it is 120. So that is the answer for the question. So we finish this class here, and in the next class we will begin the chapter differentiation of symmetric infinite series. Differentiation of symmetric infinite series is the next lecture of our lecture series, methods of differentiation. So today we finish the class here. Thank you very much.